Right, chapter number 8, final chapter, software dependability and critical system. So we'll do our best to cover all these 6 subtopics today. Critical system, dependability, achieving availability, reliability. Some of it actually we did cover in the previous chapter. Let's say availability and reliability. So some of it I will just skip through. Then the last part, safety and security. So this one, critical system, if critical system failure, critical system that fails might lead to injury, might lead to injury or loss of life or damage to the environment. There are 3 types of critical system here listed: safety critical, mission critical, and also business critical systems. Right, so dependability is an essential attribute of critical system. So why dependability is so important here? System that not dependable is mean that system that they use the word trustworthy. Okay, they are always relate this dependability with the word trust. Oh, so small. 13, 21. A system that not dependable, that means a system that are not trustworthy, unreliable, unsafe, or even insecure. So usually, system that not dependable are rejected by users. So we look at the next one here. Okay, please read through briefly the content here. Okay, as I mentioned just now, safety critical system failure might cause injury, loss of life, could also cause a serious environmental damage. So some examples of a safety critical system is like, let's say, control system for chemical manufacturing plants, or even a medical system also under this safety critical system. Weapon and a nuclear system also another example here. This is important because if any failure of this system might cause not only just injury, but also might damage or cause theft, theft to the person or environment, or damage to the environment. So what is this mission? How about mission critical system here? May result failure of some goal. Some goal directed activities. So means any failure of this mission critical system might cause failures in some expected goals. Examples here, let's say spacecraft navigation system, keeping track of the actual spacecraft positions. How about business critical system here? What's a keyword here? May result in the failure of business using the system. So this business critical system is a type of system that an organizations might rely on. The normal organization might rely on this system to carry out their normal business operations, so that the business can run smoothly and run successfully. So if let's say the business critical system fail, example here, customer accounting system in the bank, or even an online banking system, if let's say fail or interrupt third, then organization might face financial losses, yeah, reduction of their productivity, and also might cause dissatisfactions from the customer. So in long run, might affect their business performance and profits. Cause of failure here: hardware, software, and also operational failure. So this like quite straightforward. So hardware failure, example, design and manufacturing error. Component have reached their end of life. Okay, about software failure. So in this case, system software may fail because of mistakes, yeah, mistake due to their specifications, design, or their implementation. How about operational failure here? Here, talking about fail to operate the system as intended, yeah, as intended by the implementer or the designer. So these three failures are often interrelated. Let's say, for example, a failed hardware component might also mean that the system operators they have to cope with unexpected situation and additional workload. Then at the same time might put them under the stress. Yeah, when put them under the stress, when people under stress often make mistakes. What mistake? Mistake can cause the software failure. So from here can cause this failure as well. So the more work operator have, more stress they have, and then could be also might causing more software failure. Right? Can cause a no, they don't have. I mean, when they're under stress, people under stress, they might do some mistake. Yeah, this one mistake where will cause the software to fail. Next one, we look at the cause of failure. There are two categories here, direct and also indirect. Requires system to replace if direct failure. Indirect here will be the other way around. What means by dependability here? We look at the one those in highlighted here. Yeah, give me 5 seconds. Look at the definition here. System dependability reflects users' degree of trust in that system. Like I mentioned in earlier of the slide, when talk about dependability, always related to the term trustworthy. Right? System that undependable, again, means they are not trustworthy, unreliable, unsafe, or even insecure. Cover the related system attributes. So dependability also related to some of the attribute that we learned before, which is reliability, availability, and security. All these are interdependent. Dimensions. Look at the diagram here. The dependability properties here can be broken down into several simple properties here. 1, 2, 3, 4, 5. Okay, availability, reliability, safety, security, and resilience. Look at the explanations here. Okay, runs through the diagram or the hierarchy, diagram, dependability. So reliability here. Reliability, some people, they might relate this reliability to correctness, yeah, ensuring the system services perform as specified. Reliability also could relate it or include timeliness. Yeah, ensuring the information is delivered when it is required. So there are a lot of, there's still some more, you can refer to the appendix previously, there's still some more other sub attributes belong to each dependability here. So next one, principal dependability properties. So this one, I'll leave it to you, is an explanation, yeah? Definition, next one. Interdependent dependencies. So this slide shows that some of the attributes they are related one to another. Example, availability and reliability here. System operation depends on the system being whether available and also reliable. So a system that unreliable because of the data has been corrupted by external attack. So external attack here referring to security. So you can see dependability properties, they are interdependency means they are related one and another. Next slide. Dependability costs. So this graph shows the relationship between the costs and incremental improvement in the dependability. Low, medium, high, very high, ultra high, and the cost also increase. Dependability cost increase exponentially, increase levels of dependability. So the cost increase, dependability also increase. The use of more expensive development technique and hardware to achieve higher levels of dependability. So we can see clearly the relationship between both. Because of very high costs of dependability achievement, yeah, it may be more cost effective to some organization. They might believe that will be more cost effective to accept a little bit of an untrustworthy system and also pay for the failure cost instead of paying a very high cost to achieve the ultra high dependability levels. How about next one? Achieving dependability. So avoid the introductions of errors. So we look at the slide here. Let me glance to a moment. So we have, okay, so many dependability attribute depends one and another, right? So the safe system operation depends on the system might looking at the availability and also their reliability. A system may be unreliable because of the data corrupted by external attack, like just now, our example, the relationship between reliability and also security. So in that case, let's say a denial of service, another examples of a security attack, where it might cause the system unavailable. So how to achieve dependability here? How to achieve? They have a few methods listed. Avoid introduction of errors. Design verifications and validations that are effective in discovering residues errors. What is this residues error means? This is the types of errors that present, yeah? The type of errors that present after all attempts. Yeah, after all attempts to avoid introducing errors that has been done. So mean after all attempts, but still there, the error. residues, error in the system. So followed by the fault tolerance and also protection mechanism. We look at the next slide here. So example checklist, please check through the document listed here. There's a link there. Okay, configures the system correctly for the operating environment, followed by, so this one might include system, okay, this might include system capabilities to recognize a cyber attack and also include recovery mechanism. So when required and increasing levels of dependability, of course, we understand the dependability costs also increase. So the use of more expensive development technique and hardware that are required to achieve higher levels of dependability. So if we want to achieve this, then we have to consider what kind the cost. Yeah, the cost might include the investment to the hardware, software, and also the technique use. Next one, regulated system. Okay, please glance through the slide. 10 seconds. Please read through the slide. Let me highlight some words to you. Approved by external regulator. Okay, so what does this slide means? Many critical systems are regulated systems. Okay, many critical systems are regulated systems, which means that the use of the system must be approved by external regulator before the system can go into the service. Okay, clear this one? So example given here like medical devices, air traffic control system, nuclear system. So government have created a set of rules and regulations which define the standards, the standard for safety and security. This regulator, this part, regulators or regulatory bodies, what is their job here? They might ensure the company who are offering or produce a system where might comply to the rules and standards. This party, they can fine companies or even imprison the directors of the company if the regulations are breached. Okay, they have this authority. So to achieve the certifications, mentioned here. So to achieve the certifications, the company that are developing safety critical system, they have to produce extensive safety use. Yeah, they have to. This is what they, hang on, this part. Produce extensive safety case to show that they are complying to all the rules and regulations. All right, means that they are following all rules and regulations have been followed. The case, the safety case must able to convince a regulator that the system can operate safely. So we understand that developing such a safety case very costly, can be as expensive to develop the documentation for the certification here. This is what means by the content here. Next one, we look at the redundancy and diversity. A lot of theory in this chapter. Look at it a moment. two approaches here. Look at the definition here, redundancy and diversity. Redundancy means keep more than one version. Diversity, same functionality but different way. Yeah, redundancy, keep more than one version, something like backup. Diversity here, same function but different way. Let's say save it in different OS. Right? So to achieve or to enhance the dependability might rely on both redundancy and also diversity. Right? Understand, right? The meaning of both redundancy and diversity. So this redundancy is a common approach. Yeah, redundancy is a common approach to improve the reliability and also availability of the system. But however, when adding redundancy copy, when adding more versions, it might also increase the cost, and at the same time might increase the complexity of the system design. So redundancy in software engineering, this term means more than one version here, referring to duplication. Yeah, duplications, some of the component or function with the intention to enhance the reliability of the system. How about diversity here? So redundant and diverse, the diversity mentioned, same functionality but different way. So both redundant and also diverse components should be independent so that they will not, what is it? Let me here. To avoid common mode failure. Example here, component implemented in different programming language means that a compiler fault will not affect all of them. So because they have another different versions. So in our daily routine, we should always backup our data and maintain redundant copies of our data. To think of what's the best storage devices in our case. So to avoid problem with this failure, backup always recommended, but we have to think of backup or keep our data to separate devices. Make it diverse. We backup, but we don't backup at the same disk. We diverse, we backup to different devices. Let's say cloud storage. Next slide here. Process, diversity, and redundancy. So what's the content here? Any keywords? Shall not depends on single approach. Yes, agree on this. Okay, this one. Redundant and diverse process activities are important, especially for V&V, verifications and validations. So different process activity keyword complement each other and allow cross-checking. Yeah, what's the purpose of this? To avoid any error. That's the reason for also one of the reason diversity redundancy for V&V. Next one, we look at what's the challenges here. Complexity. This diversity and redundancy will make the system will enhance the complexity of the system, and sometimes could be harder to be understand. Not only that, you need to write and check but adding additional functionality might also required in the case, and the additional functionality could be used to detect what's a component failure, and also need to switch control to alternative components. So the additional complexity here might mean that the chances or the likelihood, the likelihood for the programmer make errors also might increase. So some engineer, therefore, they might think they will be best to avoid software redundancy and diversity, because the more you do, the more complexity, the chances to make errors would be also increase. So some of the engineer, they might try to avoid it, avoid diversity and redundancy. How about next slide, dependable process. Read through the content here. Ensure dependable process, ensure minimal number of software fault, well-defined, repeatable software process. Okay, this dependable software process, dependable software processes are the software processes that design to produce dependable software. Okay, software processes to produce dependable software. So the rationale to invest, rationale to invest dependable processes mean they want to have a good software processes where might help them to deliver the software with lesser error. Lesser error means less likely to fail in their execution. So the important as mentioned previously about the regulator, the system developer or the organization, it's important that they has to convince regulator with evidence that they are using the dependable processes. They are following the dependable processes. And also the most effective software engineering practice has been applied in developing the software. They have to convince regulator about this. So after that, what else? System developer also has to convince the processes they are used is consistent throughout the whole processes. So this means that the process must be explicitly defined and also repeatable. So what means by these two terms? Okay, read through or I'll just summarize to you all. So in the explicitly defined, data must be collected during the process that the development team has followed. Key is here, has followed the process as defined in the process model. What about repeatable process here? So the process can be repeated across the project with different team members, irrespective who is involved in the development. So the one that I highlighted is a key content for these two. Next slide about characteristics. So this one, I'll leave it to you. here activity. These are the activities, dependable process activities. This activity used in dependable processes. This depends, not every system are the same. It depends on what type of a system or software that they are being developed. So the following slide we look at here. So some of the activity might include in the dependable process are listed here. Okay, this for your reference. So you can go through all these. Yeah, these two slides. Dependable process activity. Next one, we look at availability and reliability. Anything new here this slide? Reliability, availability. Reliability, failure-free. Availability, available upon request. Both of these attributes can be expressed quantitatively. 0.999 means a system running for 99.9% of the time. It is reliable and also available. Some of the terminologies, yeah, table shows the reliability terminologies. So make sure here you manage to differentiate. They sound similar, but they are not the same. Please read through the differentiation. Yeah? Error, faults, error, failure. What's different, especially these three? Next slide, faults and failures. Read through the slide. Keyword. Faults do not necessarily result in system error. And also, error do not necessarily lead to system failure, because the error can be corrected by the built-in error detection and recovery. That's why will not lead to the system failure. Fault management. 3 complementary approach: avoidance, detection, and also tolerance. Okay, please highlight these 3. Okay, avoidance. Second, detection, and tolerance with example given here. Yeah, this one I'll leave it to you. Next one, reliability and specification. Reliability can only be defined normally with respect to the system specification. So in more technical definition, system failure here is a behavior that does not conform to the system specification. There are 2 problems with this definition actually. First, software specification often incomplete and incorrect. It depends on the software engineering on how to interpret the system. All right. If they are not the domain expert, then they will not implement if they are not the domain expert, of course they will not implement, they will not behave, the behavior, their behavior will not like the user expert. So the software may behave as a specified, but for user, it still fail. Yeah, because they are not the expert. They are not the domain expert. They are not the user. No matter how, but from the point of view, that's still under fail category. Except, yeah, here, let me look at the slide again. Okay, this is what I mean just now. User don't read specification, who don't know how the system is supposed to behave. No one will read the software specification document in detail. Yeah, that's why when the time we are preparing our specification document, please be don't lengthy and full with technical terms. Nobody will read except the person who are preparing the document. Please remember this. No one will read the specification document in detail except system developers. So users might therefore anticipate, okay, last two bullets here. User may therefore anticipate that the software should behave in one way when the specification says something completely different because they didn't read at all. So they might not really truly understand how the system works. So from their point of view, they just have one, not say opinion, they just has one thinking where what their perception of the software, that's it. They will not read other things, which is specified clearly in the documentation. Therefore, reliability is more important in a practice. How about availability perception here? Page does not take into account two factors: the number of users affected by the service outage and also the length of the outage. These two will not be included. How about next one? System reliability requirement. Okay, read through with all those highlighted keyword here. Okay, this one also. So the system dependability not just depends on good engineering practice, but also required attention. Yeah, attention to details when the system requirements are derived, and also the specifications. Yeah, also the specifications of a software requirement, which might ensure the dependability of the system. The dependability requirement, there are two types here: functional and also non-functional. Okay, non-functional. Functional requirement here including this is non-functional. So there are two types. Functional requirement here will define the checking and the recovery facilities that shall be included in the system. However, non-functional requirements here might include those attributes, let's say reliability and availability of the system. Metrics, this is not new. We learned this before. Yeah, we touch on mean time to failure, availability, except this and this. System reliability is measured by counting the numbers of operational failure. We'll go through metrics in the following slides. This one, POFOD. Yeah, this one. So when is the time show you this metric? This will apply when the failure on the system demand might lead to the hang on, let me rephrase my sentence. Let me read through. Okay, let me rephrase my sentence here. This probability of a failure on demand should be used in the situation where a failure on demand can lead to the system failure. Protection system that monitor the chemical reactor, and also it might shutting down the reaction if it is a overthink. So probability of failures on a demand, the measurement, yeah, they might use something like similar to the previous metrics measure quantitatively. They usually put in decimal, let's say 0.001 probability. It means that 1/1000 chances of the system failure. How about next one? ROCOF, rate of a fault occurrence, reflects the rate of occurrence failure in the system. This shall be used when demands on the system are made regularly. Yeah, for example, let's say in a system that handles large numbers of transactions, then we might specify this rate of fault occurrence for, let's say, 10 failures per day. So that means that we are willing to accept roughly average about we accept roughly about average 10 transactions per day, which will not completely perform or run successfully. Okay, clear? So another example here, 0.002 means 2 failures are likely in 1000 operational time unit. So this is a acceptable level. Yeah, 2 failure per 1000 hours of operations. So next one, mean time failure. So this metric sometimes used in reliable metrics. I believe some of you use this. Predicted elapsed time between inherent failure. Relevant for system with long transaction. Shall be longer than expected transaction length. Next one, availability. Measure quantitatively, 0.998 means 998 out of 1000 times available based on a request. This measuring AVAIL, so this measuring the probability of the system will be operate, okay, the operational period based on demand of the service. This one is not something new, so I will just continue. So example given, non-functional reliability. Look at next slide. Yeah, again, I will not read through, but I will just summarize to you. So to avoid incurring excessive or unnecessary costs, it's important we specify the reliability. Very important to specify the reliability that we or the organization really needs, rather than just simply choose a very high reliability for the whole system where my cost, where my increased expenses. Yeah, not simply just look for highest reliability, but we have to think that is the organization really need it? Next slide, functional reliability requirements. Yeah, look at the slide here. So there are 4 types of functional reliability requirement here. Checking requirement, recovering requirement. So these requirements are usually concerned with maintaining copies because recovery. Look at the term here. Concerns on what is that? The backup or redundancy copy of the system, and also have to think of how to restore the system if failure. Yeah, after a failure has occurred. Next one is a redundancy requirement. Specify redundant features. So this one we understand. Specify redundant features of the system and ensure that if, let's say, they are single component fail, will not lead to the completely loss of a service. That's the purpose of this. How about process requirement here? This will ensure good practice. Good practice is used in a development process, and the practice as specifier should be managed or able to reduce the number of faults in the system. Next slide, examples of functionality reliable requirement. So they have a 1, 2, 3, 4 based on checking. Okay, up to here. Safety, we will continue this after a short break. Everyone still here? Fall asleep already? 10 o'clock. Let's have a 15 minutes break. Go and take your breakfast. Some of you haven't breakfast yet. Are you still here? No response. Yo. Show me your little hand if you're still awake. I know this chapter a bit boring, but please be patient. This is our last chapter. Luckily, they put it as a last chapter. 15 minutes break. Go and grab your breakfast. See you after 15 minutes. Everyone here already? Elvin here, everybody here? Time goes so fast. I thought 10 minutes, but already 20 minutes. So no one, none of you absent today, right? 4. Okay, everybody here. Let's continue. We are now in slide 42. Okay, we shall manage to complete everything by today. This one about safety. So safety critical systems are the system where it's essential in the system operations that always have to be safe. Yeah, will not cause any human injury or death. The system should never damage people. Damage should never cause a danger to people or damage to the environment. Even cause a system fail also shall not be. The examples of safety critical system. Safety critical system, we already mentioned this at the beginning of the lecture just now, like the nuclear system or control monitoring system in the aircraft, process control system in chemicals, automobile control system. All those are examples, safety critical system. Safety and reliability. What's difference and what's a similarity here? Reliability and availability are necessary but not sufficient for system safety. So safety concern ensuring system cannot cause any damage. I think this topic quite straightforward. Safety means the system shall not cause any damage, whether damage to environment or lead to any injury. But however, the example given here, system reliability essential for safety but is not enough. Reliable system can be unsafe. We look at the next slide again. What's the core content or example? So this example I provided just now. System where is the essential system operation always safe, never cause any damage. Some content are repeated actually. How about next one? Safety critical software falls into 2 classes here. Primary safety critical software and also secondary safety critical system. So this primary safety critical system is a type of software that embedded as a controller in the system. So malfunctions of such software can cause a hardware malfunction, where a result will cause a human injury or environmental injury. Examples here, insulin pump control system. So system failure here might lead to user injury. How about the second class here, second category? Secondary safety critical software. Software that can indirectly, so the word here used, indirectly result in an injury. So examples here, examples of this is software, like let's say computer-aided engineering design system, where the malfunctioning might result in a design fault in the object being designed. And the fault also might cause injury to the people who design the system where cause the malfunctions. So another example for secondary safety critical system here is the the mental health care management system. So failure of the system will cause the patient might not be treated properly. So might also lead to some patient injury. They might injure themselves if you didn't provided the the stable treatment. Okay. Patient information system is safety critical as failure might lead to inappropriate treatment being prescribed. Hazard. Look at the next slide here. Slide number 46. Okay, read through the slide here. What's meant by hazard here? There are a lot of definitions. So the common definition referring to the condition where might potentially cause or contribute to an accident. Let's say failure of sensor that measuring the blood glucose. Other examples here, stuck valve in reactor control system, incorrect computation by software in navigation system, failure to detect possible allergy in medication prescribed system. So all these are hazard, all these are the condition where potentially cause accidents or lead to accidents, might cause or lead to accident. Is it something wrong with my sentence? Hazard do not inevitably result in an accident. Accident prevention action can be taken. Safety achievement, avoidance, detection and removal, damage limitation. So the system that design shall avoid hazard. What's definition? The system is designed so that some classes of a hazard simply cannot arise. So for example, in this one, safety and health code of practice issued by safety and health, issued by occupational safety and health. Let's say for the cutting system, they will require the operator to use both hands. Both hands to press the button at the same time to avoid hazard, to avoid the operator's hand hanging around at the pathway, to avoid where it might lead to potential accidents. So that's a simple example. What hazard detection and removal? Hazards are detected. For here, the chemical plant system might excessive pressures. After that, we'll open the relief valve, reduce the pressure before explosion. How about damage limitation here? The system also where my accident. Examples here, aircraft engine normally will include automatic fire extinguishers. So if a fire might often poses to any threat to the air. It's a requirement. Next one, we look at security. Grants to the notes here. System property that reflects to the system ability to protect itself from accidental or deliberate external attack, which may be accidental or, hang on, let me go through once again. Essential as most system network so that access through internet is possible. So this one, external attack. The external attacks here is possible because most general purpose computer are now network. When we open up our computer to network, so mean the potential. Yeah, they are possible. Therefore, will also accessible by outsider. Yeah, so it's possible in this case. So for some system, security is most important dimension for their system dependability. Let's say electronic commerce, or those systems that involve processing and interchange of confidential information. Yeah, security is most important to them. So 3 dimension here, CIA. Did you learn this before, CIA? CIA. Oh, you learn this in, was that in your another course? What's another course here? This one, computer security. Yeah, computer security did study this one, CIA. So confidentiality shall not be disclosed. Integrity shall not be edited, shall not be damaged, shall not be changed. Yeah, the data. Availability, data should be available anytime as required. So example, confidentiality, examples of confidentiality problem, let's say theft of credit card data from an e-commerce system, where private and sensitive data will be disclosed to other unauthorized party. How about integrity here? What's the examples here? Yeah, integrity problem. Let's say malware. Yeah, malware that deletes or alter data, or maybe man in the middle. Yeah, by alter data in between at the transit. How about availability here? This one always we give example, denial of service, where we overload the server. Or when a server overload means will avoid the authorized user accessing to a certain, let's say, online shopping platform. So in that case, with this denial of service attack, this situation will cause the system availability compromise, authorized user not able to access. These 3 dimensions are closely related. If an attack makes the system unavailable, then we might not able to update information on time. So that means that the integrity of the system may be compromised. If an attack succeeds and the integrity of the system is compromised, then may also have a taken down the repair problem. That means that not available. So at the same time, availability of the system is reduced. So they are interrelated or among these 3. Security level. From organization perspective, security to be considered at 3 different levels here: infrastructure, application, and also operational. So this one, infrastructure security, will more concern by maintaining the security of all system and also network. Application security here concern of security of individual application system. How about operational security here? Concern to secure operations and use of organization system. So straightforward definition here. So we look at next slide here. So this figure shows how an Application system relies on infrastructures of other systems in the operations. So the lower levels of the infrastructures are here. We have hardware and okay, the software infrastructure for application system. Yeah, for applications here might include, let's say, operating system, Linux, Windows, other generic application that runs a system, let's say web browser, database management system, middleware that support distributed computing and database access, or even libraries of a reusable component that's used by the application software. We look at the next one. Application and infrastructure security. What's the difference here? Look at the definition here. Application security, software engineering problem where the system is designed to resist attack. Infrastructure security, management problem where the infrastructure is configured to resist attack. So this chapter will focus on application security. We look at the next one. This system security management is not a single activity or single task, but include a range of activity. So here listed 3: user and permission management, so that the user will have the access. You look at the definition here, appropriate permission for user. Yeah, so the authorized user might have to access to the resources the time they need. For the second one, software deployment and maintenance. So this might involve updating the system regularly with new versions of patches, which might repair the security problem that have been discovered. For attack monitoring, detection, and recovery, include backup strategy. Yeah, include the backup strategy, backup activities, so that the normal operations can get back to work or can be resumed after external attack. Attack recovery. Operational security, primarily human and social issue. Concerned with ensuring the people do not take action that might compromise the system security. Users sometimes take insecure action to make it easier for them to do their job. Therefore, trade-off between system security and system effectiveness. So what does this mean? Sometimes we just leave our system open. Without lock out the system when the time because easy job make our job easier. We will not lock off all our accounts when the time we turn off computer, but it's actually open up insecure. They open up our system to access by unauthorized party. Security terminologies. We have 2 slides here. Please go through. For the next slide, differentiation between safety and security. So please go through the slide also. Yeah, please read through. Type of security requirement. There are how many types here? There are 10 types. So these 10 types of security requirement that might include in the system specifications. Identification requirement will specify whether or not the system should identify the user before interacting with them. Examples of authentication requirement here will not say example. This authentication requirement will specify how users are identified. Yeah, all these are included in the system specifications. So authorization requirement here will specify the privilege or the access permission for identified user. Immunity requirement here will specify how the system should protect themselves from, let's say, malware or any similar threat. Privacy requirement here specify how data privacy can be maintained. Yeah, altogether 10 types. Of course, we will not apply all these requirements in every system. It truly depends on type of the system, the situations of use, and also the expected users. So it's flexible, not necessarily has to be applied all the 10 types. So this one is a case example for patient information system. So please read through. This is the example to you. Misuse case. This is a scenario that represents malicious interaction with the system. Yeah, interception threat, interruption, modification, and also fabrication threats. So the explanation here is straightforward. Please go through. This diagram shows misuse cases for patient information system. So you may relate this to the case just now. Yeah, this part. They're together, continuous. So here, the use of patient information system with the added misuse cases. The added misuse cases is the one that represented in black ellipses here, these two. Next one, this table look at the use case transfer data. There are two. There are two tables here. So these two tables shows one is the original description for the transfer data use case, and then the other one is with addition. Yeah, additions of misuse case descriptions. We'll go through the differences. Yeah, transfer data and also misuse case. Next slide. Slide number 64 here. 65. Yeah, secure system design. Read through the content. Performance, usability is not something new. Sometimes it could be very difficult. Yeah, security should be designed into the system, but it is very difficult to make insecure system become secure after has been designed or implemented. So what does it mean? It means that we need to take the security issues. Yeah, we need to consider these security issues during the system design process and make a good design choices. Design it well to enhance the security of the system before the implementations. Prevention better than cure. Next one is about password checker. A security requirement, yeah. Password checker, make available, run daily. Weak password shall be reported to the system administrator. Access to the system shall only allow for approved authorized person, authorized user. All client computers should have a single approved web browser installed. Next one, a layer protection architecture. So this one related to the patient record system. Yeah, you might refer to the case just now. So this figure illustrates patient record system where the critical asset to be protected, yeah, in 3 different levels here. For individuals, records, individual patient records. So in order to access and modify patient records, the attacker here might has to penetrate 3 system layers. Platform layer protection. This is the top level where what used to control access to the platform, which where the patient record system runs. So here usually involve a user sign in, yeah, signing in to the particular computer. The second one, application level protection. Here is about getting authorizations. Record level protection. This level will check that if a user is authorized to carry out certain requested operations. Okay. That's all. Chapter number 8. So we have done all the chapter, and today we finished syllabus. Syllabus completed on time. Marathon today. So according to our plan, today we finish syllabus. Tomorrow we will complete the tutorial. Please settle tutorial question. Oops. There are only 4 questions here. Tutorial 8. Am I presenting? Eh? Can you see my slide?
Yes.
Eh, how come I didn't see my own slide here? Let me. Yeah, I didn't see my slide. What happened just now? I didn't change anything, but didn't see the slide. So mean the time that I keep on talking, you all didn't see the slide.
No. The lecture got slide.
Oh, you all look at the lecture slide, but I'm not presenting my slide. So weird. After break, change already. Didn't see. Got present. Got I don't see in my another device. Oh, now I can see. Okay. Congratulations to all of you already finished syllabus. Thought you asked tutorial slide. Okay, thank you, Kelvin. Yeah. But all this, the one that I share with you, all in the lecture notes, no worry. And the content is available in main reference books. Okay, 4 question, tutorial 8. This is our last tutorial. We are going to discuss this tomorrow. If let's say we finish tutorial 8, we will use the time to do past year. We will start from the latest past year paper. So please prepare both, yeah, tutorial 8 and also, do you all see your face there? A bit blur, no? Okay. Past year, we have 2 sets. Please prepare the latest set first. this one, 3rd of May 2021. So please prepare this solution. We will discuss tutorial at first. After that, we will continue with this past year. So another 2 days, Thursday, Friday, we will focus on revision only. On Friday, we will have a trial run. Yeah, according to my planner, trial run, last revision, and also coursework mark release on Friday. Okay, come back to the tutorial here. Tutorial question number 1. Compare, contrast safety and resilient system dependability. Question number 2. You may read in further the source listed here. Identify only 2 dimension, justify. So frankly speaking, this course easy to pass, but not easy to score A. Yeah, you all get the point. All the points are there, but how you justify the answer is truly depends on the quality of your answer. The student has to be really understand. If I memorize, cannot. Have to be understand the cases given from what you learn in the lecture notes, and then you need to further elaborate. That's not easy. Yeah, easy to pass, but not easy to score excellent or A. Please put effort. Question 2B, 2 appropriate safety requirement. So by the time, so you need to go and find out what is this insulin delivery system. Please read, go and find out extra information on this. Yeah. Go in detail, understand, then only you can think of what are the requirements that you can suggest here. Question number 3. Include mission critical system and business critical system. After that, provide dimension, justification. Question number 4, importance of redundancy approach to business critical system. So it means before you answering this question, you need to find out what are the examples of business critical system. Find out the one that you are more familiar with. There are plenty of examples, but which example you are more, are more related to you. More related to you, you'll be more understand. Then from the time you explain, you can give more, you can manage to elaborate in detail. If you're using those systems that you ever heard but you don't know, that means a bit hard for you to justify your answer. Okay, example. So 4 questions, please put some effort. Don't just wait for the answer, because our answer, they are no perfect. Yeah, 100%, they are more than one answer. More than one perfect answer. Please put some effort in the tutorial and pass your question. Yeah, we finish our class on time today. 9 to 11. That's all from me today. Do you have any question?
No.
No question. All right, noted, Ivan. If no question, you may leave the meet session. I'll meet you tomorrow. Yeah, I'll meet you again tomorrow. Take care, everyone.
Okay, Miss. Thank you.
Welcome.